Today I want to talk about factoring polynomials that are in the form of x squared plus bx plus c. Now in this particular form, notice that there is no coefficient in front of the x squared. So the methods that you're going to learn today only involve cases where there is no coefficient in front of the x squared. In a future video, we will cover factoring polynomials in which there is a coefficient in front of the x squared that is other than 1. So let's get started with the steps that we need to follow in order to factor polynomials in this form. So what we have to do here is we have to determine, first of all, what are the factors of c? We have to find all of those. And then when we figure out those factors, which we'll list, and I'll show you how we'll list them, we then need to determine which of the pair of factors which we have found that when they're added together, they give us the sum of b. Now when I'm talking about b and c here, I'm referring to this form as we said at the beginning. So this is c. We're going to find the two factors that multiply to give c, and those same two numbers need to add up to give us b. Okay? So let's take a look at some examples here to hopefully give a clearer picture on this. All right, let's factor this. So the first step we said where we need to list all the factors of 32. We said c, but in this case c is 32, okay? So we're going to find all those factors, and then each pair of factors that we find, we're going to write down the sum. Okay, so what are some factors of 32? Well, we know that 1 and 32 is an obvious choice for two numbers that multiply to give us 32. Another set of numbers that gives us 32 is 2 and 16. Another set of numbers is 4 and 8. Now I believe that's all of the factors here of 32. Let's take the sum of each of these pairs of factors. We have 32 and 1. If we add those, we get 33. We have 2 and 16 here. If we add those, we get 18. And we have 4 and 8, and if we add those, we get 12. If we recall, we said that the two steps were find the factors, multiply to give 32. So find the factors of 32. And those two factors that we find need to add up to give us b, which in this case is 18. So if we look here, this is the one that we need to go with. So let's look at the two numbers. We have 2 and a 16, so we can simply write it as x plus 2 and x plus 16. And this is this trinomial here factored down. Now eventually you'll be able to do this without having to write this whole table out. You could sit here and look at this and say, okay, two numbers that multiply to give me this and add to give me that. Okay, those are 16 and 2. And then you can just write it down to here like this. Let's do another example. Okay, here's the next one. Factor x squared minus 6x minus 16. Now we picked this one for a particular reason, and that reason has to do with negative signs. When you're dealing with factors, you have to keep account of the sign. Notice in the last example that we didn't have to really worry about it because everything was positive. So these signs play a major role in determining which factors we're going to pick. Let's list all the factors of negative 16, and you'll see what I mean. First off, we have 1 and negative 16. That is a possible factor. Now, we also could say negative 1 and positive 16. So you can see now how important it is that we deal with these negative signs, because both of these, even though they're the same numbers ignoring the signs, they will give us two completely different sums when we get over here and look. Let's keep looking here. We have 2 and we have negative 8. We also have negative 2 and 8. Now notice I did not need to write this one again because they're both 4. So it would have been the same thing twice. Let's now list the sums. We have 1 and negative 16 here. If I add those together, I get negative 15. Negative 1 and 16 added together, that's positive 15. Adding 2 and negative 8 gives us negative 6. Negative 2 and 8, that gives us positive 6. And when we add these two together, we simply get 0. Now, if we're looking right here at this board, we're trying to find the numbers that when you multiply them together, you get B. Look what B is. B is negative 6. So clearly this one is the correct choice to pick. So these two numbers are the ones that I want. Now the way you write this down is, let's write it up here so you can see it. X plus 2 and x minus 8. Notice this 2 and this negative 8, they came directly from this list over here. So these numbers come from the two numbers that multiply to give me this, the two numbers that multiply to give me negative 16 in this case, and those same two numbers, when I add them, they need to give me negative 6. Looking at them, we can tell, okay, negative 8 times 2, that's negative 16. Negative 8 plus 2, that's negative 6. So we got it right. If we were to FOIL this back out, would you be surprised to know that you'll just get this back? So basically what we're doing is we're going, if you remember when we did the FOIL expansion, we went from here to here, and now you're doing this technique to go the other way around, from here back to this. Okay, let's take a look at one other example, but this time we're not going to write down the table. Let's see if we can figure it out without it. All right, let's take a look at this one. Notice we need to factor it, and we're going to try to not do it with a table. So, what are the numbers that I can think of that multiply to 44, and I can somehow associate them with 7? Let's think. Well, if I say 2 and 22, there's no way that I'm going to get to 7, but that would work. Obviously, 1 and 44, there's no way. But what about 4 and 11? We can see a 7 can come about from 4 and 11 based on some subtraction or addition, okay? So we know for a fact that our numbers are going to be 4 and 11. We know that. The key here is we need to figure out which one of them is negative, because we know that one of them is negative because this number is negative. And in order to get a negative number, you have to be able to multiply two numbers and one of them is going to be negative, okay? So which one of these is negative? We're going to figure it out. If I said this one was negative, well, it looks like we got it right on the first try. Since this one's negative, a negative 11 times 4, this of course is negative 44, and negative 11 plus 4, well, this is negative 7. Notice how we got these two numbers here. Now, if we were to put the negative 4 here first and made that positive, try that yourself and notice you will not get these two results. You will get this one, but you will not get the sum that you're looking for. All right. Since we have now our two numbers, we simply can just write the answer like this. Plus 4 is here, and the minus 11 is here. And this is factor form of that polynomial right there. So this one we did without the table, but if you need the table, write it down. Keep doing it until you get it. But eventually, that's what you're doing in your head as you go on, okay? You're doing it this way. And usually, after you get good at this, students typically get good at this rather quickly. You really don't have to think too much about it. You just kind of get to it. Now, if these numbers were very large, of course, you'd have to figure it out. But for the basic numbers, smaller numbers like that, they can typically figure it out rather quickly. Let's look at one last example here. Suppose you're asked to factor this one. Now, Some of you may be thinking, well, what is this? This is not in the form that you said it was going to be. Well, that brings up an important piece of information. The first thing you always want to do in any problem that it asks you to factor is you always want to find out, is there some common factor between these terms? And if we look, all three of these terms have the number 3 in common and an x in common. This, in fact, is the GCF of this particular polynomial. So I can factor out a 3x here. And when I do that, what's left here? Well, the 3, if I divide these two, the 3's go to 1. And if I subtract my exponents here, I'm left with 2. So that's x squared. Then, if I divide these two, the 15 divided by 3, that goes to 5. And one of the x's goes, so it's just x. And here, the x's divide out to 1, and 18 divided by 3 is just 6. Now look at what we have. We have this something inside here that we're familiar with from this section. We now have something that we can factor. Two numbers that multiply to give me 6 and add to give me 5. Those numbers can either be 1 and 6 or 2 and 3. If I add 1 and 6, I get 7. That's not what we want. If I add 2 and 3, I get 5. This one is the one that we want. If I add 2 and 3, I get 5, and this one is the one that we want. So we can write our final answer like this. And we have successfully factored this polynomial right here. Finally, let's go over some of the final notes here from this section. You always want to first check to see if there's any common factor that you can take out of the polynomial. Think about our last example. We were able to factor out 3x, and then we were able to do the factoring in this form. Once you get it to this form, final note 2 is, the way you do this is that you find the factors of C, those two numbers need to add up to give you B. If you understand these two concepts, you'll be able to do any problems in this section.